Algebra 4-2, Part 2. This is where we're going to talk about linear functions. Linear means it makes a line. Function means that every inputs are x values, has only one output. Outputs are y values. So when you put 5 into a linear function, you always get 3, or you always get 4. You don't get both. Every input has one output. Okay, so when we're talking about linear functions, we have 3 different kinds of lines. We have diagonal lines. Any diagonal line could be going this way like this one, or this way, anything diagonal. Every single diagonal line is a linear function. That's a linear function. Okay? Horizontal lines. So we'll write function here. Horizontal lines. Horizontal lines are all going horizontal, like the horizon. All of them are also functions. They're functions. Every horizontal line you can graph is a function. Vertical lines. Vertical lines are not functions. Why aren't they functions? Because no matter what x I put in, I get the same number for y. And that's what says it's not a function. If you put 1 in for x, you get 3 for y. If you put 2 in for x, no, I'm saying that backwards. You put x in, x might be 3, and you get a different number for y. For instance, let's say that this is 3 right here on our graph. So this would be the point 3, 0 right here. Then you would have 3, 1, and 3, 2, and 3, 4, and 3, 5, and 3, 6, and 3, negative 1, and 3, negative 2, and 3. So every time you put 3 in, you have lots of possibilities. Vertical lines are not functions. Not functions. Vertical lines are just vertical lines. They're linear equations, but they're not linear functions. Let's go back. So, diagonal lines, linear functions, yes. Horizontal lines, linear functions, yes. Vertical lines, no. Not a linear function, just a linear equation. In most linear functions, or in most linear equations, either one, the domain is all real numbers. You can use any number you want. But sometimes they give you a problem where they tell you the domain, and they tell it like this usually. Like they would say, the domain is x is greater than 0. That means for the x's you can only pick numbers that are greater than 0. They might say x is greater than or equal to 0. Then you would pick x's that were 0 and greater. They might say x is less than 0. Then you would have to pick x's that were negative numbers, less than 0. They could even say x is less than 5. Then you would have to start with 4 and go down. 4, 3, 2, 1, 0. They might limit you. The domain can be limited to a certain set of numbers. Most of the time, we can use any number in the world for the x values for the domain, but sometimes in a problem, they tell us specific x values to use, and they do it like this. Okay, here's our first problem. Graph the function y equals negative 1/2 x plus 4 with domain greater than or equal to 0. So that means our x's can start at 0 and get bigger, but we can't have any negative x's, only positive ones and 0. Then, after we finish, we have to identify the range. So the first thing to do is make an input-output table. Now, I really don't enjoy fractions, so I'm going to try to pick some x's that are greater than 0 that will make the fraction go away. So first, I'm going to start with 0, because 0 times negative 1/2 is 0, plus 4 is 4. And then I'm going to use 2. The reason I skipped 1 is 1 is going to give me negative 1/2. It's going to be harder to graph. 2 is going to give me negative 1. So negative 1 plus 4 is 3. Then I'm going to use 4. 4 times negative 1/2 is negative 2. Negative 2 plus 4 is 2. Now I'm going to graph these points. So the first one is 0, 4. The second one is 2, 3. The third one is 4, 2. Now, when I draw my line, since I can't have any negatives in my domain, there's nothing over here. My line actually is going to start here, and it's going to go this way. And it's not really a line, it's really a ray, because this is just going to be a point. It's not going to be an arrow, because it doesn't keep going this way. So, when I draw my line, I go this way. This side gets an arrow, because I could have some more x's that are positive. Now, remember it asked us to tell the range. So, let's think about that. The range of this function. That means the y values. Now notice, when I put 0 in, I got 4. Am I ever going to get anything bigger than 4? Is this graph that we made ever going to get bigger than 4, or is it going to keep going smaller in the y's? Say 4, 3, 2, 1, 0. It's going to eventually go negative. So, look at your y-axis. And you say, oh, here's 4. Look, this graph is going down, so there's nothing bigger than 4. So, that means the range of this function is every single y that's either equal to 4 or less than 4. So the range is y, all the y's that are smaller or equal to 4. So we did what they asked us to do. We graphed it by making an input-output table. We picked our x's wisely, but we only used positive x's. And we found out that the biggest number on this graph is going to be 4, so the range is y is less than or equal to 4. Okay, here's your video homework. Let me give you a couple of hints. The first thing you need to do is make an input-output table. Make sure on your input-output table you're using x values that are less than or equal to 0. So 0, negative 1, negative 2, like that. Don't use any x's that are positive. Use 0, 1, negative 1, negative 2, negative 3. Okay. Then, after you get it graphed, look at the graph and figure out the range. Look at the y values. Where does it go on the y-axis? What's the, which way is it headed? And you're going to write your range like the x is written. Okay? Good luck. Have a great evening.